What if everything you thought you knew about reality was just one version of an infinite tapestry, one thread in a cosmic fabric woven with countless parallel worlds? There's a moment in every great discovery when the impossible suddenly feels within reach, and right now, we're standing on the edge of one of those moments. The idea of stepping into another universe, a place where history unfolded differently, where alternate versions of ourselves might exist, has long been the stuff of science fiction. But what if it wasn't? What if the first human journey into a parallel reality isn't just a dream, but a scientific frontier we're closer to crossing than ever before? Think about it. Somewhere out there, in the vast, uncharted territories of existence, there could be worlds where dinosaurs never went extinct, where empires rose and fell in ways we can't even imagine, or where you made one different choice that changed everything. The sheer scale of that possibility is enough to send a shiver down your spine. And here's the thing, scientists aren't just fantasizing about this anymore. There are at least 30 groundbreaking theories, each one more mind-bending than the last, that could finally unlock the door to parallel universe travel. From quantum entanglement to multiverse models, from wormholes to brain worlds, the ideas on the table aren't just wild speculation. They're serious, calculated attempts to answer one of humanity's oldest questions. Are we alone in existence, or is there someone else out there? This isn't just about science, it's about the very nature of reality itself. Imagine the implications meeting another version of yourself, witnessing history unfold in ways you never thought possible, or discovering that the laws of physics as we know them are just one set of rules in an infinite cosmic game. The journey to understanding parallel universes isn't just a trip through space, it's a voyage into the deepest mysteries of existence. And today, we're diving headfirst into those mysteries, exploring the 30 most compelling theories that could make parallel universe travel a reality. Buckle up, because by the end of this, you might never look at the universe the same way again. Picture a bridge made not of steel or stone, but of pure quantum connection. The quantum bridge hypothesis suggests that the strange, invisible links between entangled particles might be more than just a quirk of physics. They could be secret doorways, tunnels weaving through the fabric of reality itself, connecting our universe to others. Here's how it works when two particles become entangled. No matter how far apart they are, changing one instantly affects the other. It's as if they're whispering to each other across space, or maybe across dimensions. Now take the famous double-slit experiment, where particles behave differently when they're being observed. It's like reality is shy, changing its behavior the moment we look. But what if that flicker of uncertainty isn't just randomness? What if it's a glimpse into other universes bleeding into ours? Some researchers believe these quantum oddities aren't just glitches, they're evidence of parallel realities overlapping, interacting in ways we're only beginning to decipher. Think of it like radio static, just noise until you find the right frequency. Quantum entanglement might be our static, and somewhere in that chaos, there's a signal from another world. Experiments in labs today are pushing the boundaries, trying to stabilize these quantum bridges long enough to send not just particles, but information, maybe even matter, across. Imagine a future where stepping into another universe isn't about rockets or wormholes, but about tuning into the right quantum frequency, like finding a hidden channel in the cosmic static. The implications staggering. If even a single atom could make the jump, it'd rewrite the laws of physics as we know them, and if we could scale it up, well, that's when the real adventure begins. Now, let's go from the invisible threads of quantum entanglement to something far more tangible: wormholes, those cosmic shortcuts straight out of sci-fi. Imagine folding a piece of paper so two distant points touch, then punching a hole straight through. That, in essence, is how a wormhole could connect not just distant parts of our universe, but entirely different realities. These theoretical tunnels, known as Einstein-Rosen bridges, were first predicted by Einstein's equations over a century ago. But here's the twist: they're not just mathematical curiosities. They might be the key to stepping into another universe. The catch: wormholes, if they exist, are notoriously unstable. Picture a tunnel made of soap bubbles. It collapses the moment anything tries to pass through. That's where exotic matter comes in. This hypothetical substance, with its negative energy density, could act like cosmic duct tape, holding a wormhole open long enough for something or someone to traverse it. Think of it as the universe's version of propping open a revolving door. Experiments in labs are already mimicking these conditions on microscopic scales, manipulating space-time in ways that hint at the possibility of stabilizing these gateways. But the wildest part: some theories suggest wormholes might not just connect points in our universe. They could link entirely separate brains, floating membranes of reality in a higher dimensional space, like pages in a book. If that's true, finding the right wormhole could be like flipping to a different chapter of existence, where history, physics, even the nature of life itself might be rewritten. The implications are dizzying. A stabilized wormhole wouldn't just revolutionize travel, it'd redefine reality. Imagine stepping through a gateway and emerging in a world where gravity behaves differently, where light moves at another speed, or where you're meeting a version of yourself who made all the choices you didn't. The science is still young, but the dream is alive. Wormholes might not just be bridges through space, but through the multiverse itself. What if the faintest ripples in the fabric of space-time aren't just cosmic background noise, but echoes of neighboring universes bumping into ours? The Multiverse Collision Theory paints a breathtaking picture. Our universe isn't drifting alone in the void. It's one of countless bubbles in an endless cosmic foam, occasionally brushing against others with enough force to leave marks we might already be detecting. Take the cold spot in the cosmic microwave background, that faint afterglow of the Big Bang. Stretching across a patch of sky larger than any galaxy, this mysterious region is significantly colder than its surroundings, as if a cosmic eraser smudged part of the universe's baby picture. Mainstream explanations like supervoids don't quite fit. But what if that chill is a fingerprint, a bruise left by a collision with another universe trillions of years ago? Here's where it gets wild. When two bubble universes graze each other in the multiverse, the energy released wouldn't just vanish. It could ripple through space-time like a stone dropped in a pond, leaving behind anomalies in temperature, density, even the very structure of reality. These wouldn't be wormholes or quantum bridges, they'd be natural fractures, temporary windows forced open by the sheer force of cosmic traffic. Picture two soap bubbles merging for a split second before pulling apart. Now scale that up to universes. The math behind this is staggering. Simulations show such collisions would create distinct signatures, circular patterns in the cosmic microwave background with sharp edges like cosmic bite marks. And guess what? Astronomers have found not just the cold spot, but other unusual asymmetries that defy standard cosmology. Could these be the scars of ancient universe collisions? Imagine standing at one of these fractures. For a fleeting moment, you might peer into a reality where physics operates differently, where stars burn another color, time flows backward, or atoms never formed. The portal wouldn't last. The universes would rebound like colliding pendulums, but in that instant, the impossible could become reachable. Critics argue these anomalies could still be statistical flukes. But here's the tantalizing part. Next-generation telescopes like the Simons Observatory are mapping the cosmic microwave background with unprecedented precision. If they find more of these peculiar patterns aligned in ways only collisions could explain, the multiverse might shift from philosophy to physics. Think about what that means. We might not need to build a gateway to another universe. We just need to find where the cosmos has already torn itself open. The greatest journey in history could begin by tracing the cracks in our own sky. String theory spins a cosmic web so intricate, it makes our familiar three dimensions seem like just the first page of an endless book. At its heart lies a radical idea. The universe isn't built on point-like particles, but on tiny, vibrating strings threads so small, if an atom were the size of the solar system, a string would be no larger than a tree. But here's where it gets mind-bending. These strings don't just wiggle in the dimensions we know. They dance through 11 of them, 7 hidden dimensions curled up so tightly we've never noticed. Think of it like this: an ant crawling on a telephone wire sees only a one-dimensional line, but to a bird soaring past, that wire is part of a vast three-dimensional world. What if we're the ants? Those extra dimensions could be folded around us right now, packed into every corner of existence. And inside those folds, entire parallel universes might be lurking, separated from us not by distance, but by the very geometry of reality. This is where brains come in short for membranes. Picture our universe as a slice of bread floating in a cosmic loaf, with other slices stacked alongside it. Each brain could host its own version of reality, complete with unique laws of physics. The space between them, that's the bulk, a higher dimensional realm where gravity might leak from one brain to another, explaining why it's so weak compared to other forces. Now imagine plucking a guitar string. The pitch changes based on how it vibrates. In string theory, those vibrations don't just produce particles, they could unlock dimensions. Certain vibrational modes might resonate with hidden folds in spacetime, creating temporary bridges between brains. It's not about building a spaceship to cross the void. It's about finding the right cosmic frequency to step through the walls of our own universe. Experiments like the Large Hadron Collider are hunting for clues: tiny extra dimensions, or even microscopic black holes that could wink into existence if strings collide with enough energy. And if they succeed, the implications would rewrite existence. A civilization mastering these vibrations wouldn't just travel the stars, they'd surf the multiverse, tuning into realities where every possible version of history unfolds in parallel. The gateway isn't a machine, it's the universe itself singing in dimensions we're only beginning to hear. What if everything you see, touch, and experience is just an illusion? A three-dimensional movie projected from the edges of the universe. That's the spine-tingling premise of the holographic principle, a theory so radical it turns reality inside out. Imagine the cosmos as a giant cosmic projector screen, where every star, planet, and person is just a flickering image encoded on a distant two-dimensional surface. But here's the kicker. If our 3D world is really a hologram, then the key to unlocking parallel universes might not lie in crossing vast distances, but in rewriting the code on that hidden 2D boundary. Think of it like a video game. The lush forests, roaring cities, and intricate characters you see on screen don't actually exist inside your console, they're generated from lines of code. In the holographic universe, we're the characters, and the real action is happening on a flat, distant surface we can't perceive. Physicists studying black holes stumbled onto this idea when they realized the information swallowed by these cosmic vacuums doesn't vanish. It gets imprinted on their event horizons like data etched onto a DVD. If a black hole's surface can encode everything inside it, why not the entire universe? Now, here's where it gets wild. If we could somehow access or alter that 2D boundary, the universe's source code, we might not just glimpse other realities, we could step into them. Picture a programmer editing a game's files to unlock hidden levels. Manipulating the holographic boundary could let us switch between versions of reality like changing channels, stepping into worlds where the rules themselves are different. Some models even suggest quantum entanglement. Spooky connections might be threads stitching these holograms together, meaning the gateway to another universe could be hiding in plain sight, woven into the fabric of quantum weirdness we're already observing. Experiments are already testing this. Fermilab's holometer is hunting for telltale pixelation in space-time, evidence that reality has a finite resolution, just like a hologram. If they find it, the implications would be staggering. Suddenly, building a portal isn't about engineering some massive machine. It's about learning to reprogram reality at its most fundamental level. The greatest journey might not require a ship at all, just the cosmic equivalent of pressing Ctrl plus Alt plus Del on the universe itself. Dark energy, the mysterious force accelerating the universe's expansion, might be hiding more than just empty space between galaxies. Picture a river carving canyons over millennia. Now imagine that river is dark energy and the canyons it's carving are tunnels through space-time itself. This isn't just hypothetical. Some physicists argue that in regions where dark energy concentrates, its repulsive gravity could twist the fabric of reality so violently that it punctures through to other universes. Think of it like stretching a rubber sheet until it tears. Dark energy's relentless push against the cosmos might create weak spots, areas where space-time becomes so thin, so warped that it fractures. These wouldn't be wormholes held open by exotic matter. They'd be natural tunnels forged by the universe's own expansion, like cracks in drying clay. The math behind this is staggering. In certain models, if dark energy's density spikes locally, perhaps near collapsing supermassive black holes or ancient cosmic voids, it could generate enough negative pressure to rip space-time apart at the seams. Here's where it gets wild. These tunnels wouldn't lead to other points in our universe. They'd connect to entirely separate space-time fabrics, other universes with their own laws of physics. Imagine a whirlpool spinning so fast it drills a hole through the ocean's surface, linking two disconnected bodies of water. Dark energy tunnels could function the same way, but for reality itself. Astronomers might already have clues. The mysterious Great Attractor, a gravitational anomaly pulling thousands of galaxies toward it, could be one such fracture, a cosmic drain where dark energy's grip has loosened spacetime's weave. But how would we traverse such a tunnel? The answer lies in dark energy's anti-gravity nature. Unlike black holes, which crush everything that enters, these tunnels would repel matter outward. A spacecraft could theoretically ride the wave of expanding spacetime like a surfer catching a never-ending swell. The challenge? These tunnels would be transient, snapping shut as dark energy's density fluctuates. Timing would be everything, a leap of faith into the universe's stretching seams. Critics argue we've never observed spacetime tearing naturally. Yet dark energy itself was once dismissed as impossible until astronomers measured the universe's accelerating expansion. If these tunnels exist, future telescopes mapping dark energy's distribution might spot them regions where gravity pushes instead of pulls, where light bends the wrong way. The most profound journeys often begin by embracing the unknown. And if dark energy holds the key, the greatest exploration in history might start where the universe is unraveling fastest. What if the universe isn't just governed by laws of physics, but by lines of code? The simulation hypothesis suggests our reality might be an advanced digital construct crafted by some unfathomable intelligence. And if that's true, then every glitch, every unexplained anomaly could be more than just a quirk of nature. It might be a backdoor, a crack in the simulation's architecture leading straight to another world. Take déjà vu, for instance. That eerie sense of reliving a moment could be more than a trick of memory. In a simulated reality, it might signal a buffer overflow, a momentary overlap where data from another instance of the simulation bleeds into ours. Or consider quantum indeterminacy, where particles exist in multiple states until observed. Could that be the simulation's rendering engine struggling to keep up, leaving gaps where alternate versions of reality flicker through? The idea isn't as far-fetched as it sounds. Physicists have already proposed tests for the simulation hypothesis, like hunting for pixelation in the fabric of space-time, evidence that the universe has a finite resolution, just like a video game. If such glitches exist, they wouldn't just prove we're in a simulation, they'd reveal its weak points. Imagine hackers probing a system for vulnerabilities. A civilization that understood the code underpinning reality could exploit those flaws, not to crash the system, but to jump, rewriting their coordinates to exit one simulated universe and enter another. Think of it like speedrunning a game. Players use exploits to clip through walls or skip levels actions the programmers never intended. If our universe operates on similar logic, finding its undocumented shortcuts could let us bypass the boundaries between realities. Some theories even suggest that black holes might be cosmic garbage collectors, places where the simulation deletes or compresses data. What if they're also transfer points? A carefully engineered escape route could turn them into portals, ejecting travelers into a sister simulation running on the same cosmic server. Of course, the biggest hurdle isn't just finding these glitches, it's surviving them. Manipulating the code of reality could have catastrophic side effects, from localized physics failures to total system crashes. But for a species bold enough to treat the universe as software, the ultimate cheat code might not be immortality or infinite energy. It could be the ability to press escape and load a different world entirely. Time crystals sound like something ripped straight from the pages of a sci-fi novel, but these bizarre structures are very real, and they might just hold the secret to stepping into another universe. Unlike ordinary crystals, which repeat their atomic patterns in space like a diamond's lattice, time crystals repeat in time. They're like a pendulum that never stops swinging, a heartbeat built into the fabric of reality itself, constantly cycling between states without ever losing energy. Now, here's where it gets mind-bending. Some physicists believe these perpetual motion machines of the quantum world could act as tuning forks for the multiverse, vibrating in perfect sync with parallel realities. Picture two identical grandfather clocks placed side by side. Over time, their pendulums begin to swing in unison, locked into the same rhythm through tiny vibrations passing through the wall. Time crystals might work the same way, except the wall is the fabric of space-time and the clocks are entire universes. If two realities share similar quantum signatures like cosmic twins, their time crystals could theoretically resonate across dimensions, creating fleeting moments where their vibrations align. In those instants, the boundary between worlds might thin enough to cross. The key lies in a phenomenon called quantum synchronization. Just as lasers produce coherent light by aligning photons, synchronized time crystals could produce coherent realities, bridges where the rules of one universe momentarily echo into another. Experiments at places like Google's Quantum AI Lab have already created primitive time crystals in qubits, observing their eerie ability to maintain rhythm without energy input. Now imagine scaling that up. A sufficiently advanced time crystal network pulsing in perfect harmony with another universe's counterpart could carve out a stable corridor between them, a doorway held open by the sheer force of resonant repetition. The strangest part, these gateways wouldn't require exotic matter or black holes. They'd emerge naturally from the dance of quantum mechanics, like a harmonic overtone humming between two cosmic instruments. The catch, we'd need to find a parallel universe with matching time crystal vibrations, like tuning a radio to the exact frequency of a station in another dimension. But if that's possible, stepping into another reality might be as simple as waiting for the ticks of two universes to align. Of course, skeptics argue we've barely scratched the surface of time crystal behavior, let alone multiverse resonance. But here's the tantalizing twist. If parallel worlds share even a fraction of our quantum rules, their time crystals could already be whispering to us echoes of alternate realities, pulsing just out of phase with our own. The gateway might not be something we build, it's something we listen for, and when the rhythm matches, the door could swing open on its own. Black holes have always been the universe's ultimate mysteries, cosmic vacuums so powerful, not even light can escape their pull. But what if these terrifying giants aren't just one-way trips to oblivion? What if, on the other side of that crushing darkness, there's a door, a cosmic exit ramp spewing matter and energy into another reality entirely? That's the startling premise behind black hole-white hole bridges, a theory so audacious it reimagines the most destructive objects in the cosmos as potential gateways to parallel universes. Let's break it down. A black hole's gravitational grip is so intense it warps space-time into a singularity, a point where the laws of physics as we know them simply break down. But Einstein's equations also hint at something stranger: white holes, the theoretical opposite of black holes. While black holes suck everything in, white holes would violently expel everything out. They're like cosmic geysers, blasting matter and energy into existence rather than swallowing it. The catch: we've never observed one, at least not in our universe. Here's where the theory gets wild. Some physicists speculate that black holes and white holes aren't separate objects at all, they're two ends of the same tunnel. Picture a drain at the bottom of a sink, sucking water down the pipes. Now imagine that same pipe leads not to a sewer, but to a fountain somewhere else, spraying that water back into a brand new basin. In this cosmic plumbing, the black hole is the drain, and the white hole is the fount. And in another universe, matter falling into a black hole here could be violently reborn in a parallel reality, ejected from its white hole counterpart like a cosmic rebirth. The math is mind-bending. Solutions to Einstein's field equations, like the Kerr metric for rotating black holes, suggest that under extreme conditions, a black hole singularity might not be a dead end but a bridge, a wormhole threading through higher dimensions. And if that's true, the white hole on the other side wouldn't just be a hypothetical oddity. It'd be the smoking gun of a parallel universe, a place where the laws of physics could be radically different. Imagine a star collapsing into a black hole in our cosmos, only to explode back into existence elsewhere, not as a supernova, but as a white hole's dazzling eruption in a reality where time flows backward, or where gravity repels instead of attracts. Of course, there's a reason we haven't found these bridges yet. The journey through a black hole would be messy. The intense tidal forces near the singularity, what physicists call spaghettification, would stretch anything crossing it into atomic noodles. Even if you survived the white hole's explosive eggs, it might shred you into raw energy. But here's a tantalizing thought: what if advanced civilizations have already figured it out? If a species could harness the energy of a spinning black hole, or shield matter in some kind of quantum bubble, they might be able to surf the singularity like a wave, riding it straight into another universe. And there's another twist. Some models suggest white holes could explain one of astronomy's biggest puzzles: fast radio bursts. These intense, millisecond-long blasts of energy appear out of nowhere with no obvious source. Could they be the distant echoes of white holes in other universes, firing jets of radiation into ours? If so, we might already be witnessing the fingerprints of parallel realities, cosmic SOS signals from the other side of the multiverse. The idea is still speculative, but it's not pure fantasy. Researchers are actively studying the quantum behavior of black holes, searching for hints of information preservation, clues that what falls in might not be lost forever, but transmitted somewhere else. If they find evidence of white hole emissions or quantum signatures that defy local physics, the implications would be staggering. Black holes wouldn't just be cosmic dead ends. They'd be the universe's most extreme travel agencies, offering one-way tickets to realities beyond our wildest imagination. What if the key to visiting another universe isn't about moving your body, but shifting your mind? The consciousness transfer theory flips everything we've discussed on its head, suggesting that parallel universe travel might not require spaceships or wormholes at all. Instead, it could be as intimate as a thought, a seamless leap of awareness into another version of you in a distant reality. Imagine standing in front of a hallway with infinite doors, each leading to a world where your life took a different turn. One door opens to a universe where you pursued that risky career move, another where you never moved cities, yet another where humanity evolved under a different star. Now picture stepping through one not physically, but by becoming the version of you that already exists there. This isn't science fiction. Cutting-edge neuroscience and quantum theories are converging on a radical idea. Consciousness might not be tethered to a single brain, but exist as a waveform, a ripple spread across the multiverse, echoing into every possible version of yourself. The mechanics: think of your brain as a radio receiver tuned to one specific frequency, your current reality. But what if you could retune it? Technologies like transcranial magnetic stimulation are already proving we can alter perception, memory, even self-awareness with targeted electromagnetic pulses. Now extrapolate that to a future where we don't just tweak consciousness, we relocate it. By entangling your brain's quantum states with those of an alternate version, a process called quantum mind linking, you might effectively download your memories, emotions, and sense of self into another universe's counterpart. It's less about teleportation and more about synchronization, merging two streams of awareness until one becomes dominant. The implications are dizzying. Ethical dilemmas aside, would overwriting another you count as murder? This method sidesteps physics' toughest barriers. No need to solve warp drives or survive black holes. If consciousness is fundamentally non-local, as some quantum theories suggest, then the universe's greatest journey might happen entirely within the space between your ears. Experiments are already hinting at this possibility. Studies on near-death experiences report subjects feeling pulled toward alternate lives, as if their awareness briefly brushed against parallel existences. And in labs, quantum cognition research shows human decision-making might be influenced by superposition, our choices playing out in multiple realities simultaneously. The bridge isn't out there, it's in us, but here's the kicker: if consciousness can hop universes, how would you even know it happened? The you in this reality might simply blink and suddenly remember a life you never lived in a world that feels both alien and intimately familiar. The ultimate frontier isn't space, it's the mirror. Every now and then, the universe does something strange. It throws up a glitch, a blip in reality so bizarre that it defies logic. One of these glitches might just be the key to stepping into another world. The Boltzmann brain paradox is a terrifying, mind-bending thought experiment that asks a shocking question. What if everything you remember, everything you think you are, just popped into existence a moment ago? A momentary flicker of consciousness formed by pure random chance. It sounds like something from a fever dream, but it's grounded in real physics. And if a self-aware brain can spontaneously assemble from quantum chaos, even for an instant, could the same bizarre process crack open temporary doorways to other universes? Here's how it works. In an infinite cosmos, given enough time, even the most improbable events become inevitable. Atoms randomly jostling in the void could, purely by accident, arrange themselves into a fully formed human brain, complete with false memories of a life never lived. That's the Boltzmann brain, a ghost of consciousness conjured from nothingness. But what if these quantum fluctuations don't just create phantom minds? What if they stitch together something even stranger, microscopic tears in space-time, fleeting wormholes threading through the multiverse? Picture the quantum foam, the seething sea of virtual particles that physicists believe makes up the fabric of reality. At scales smaller than an atom, particles blink in and out of existence constantly, borrowing energy from the universe only to vanish moments later. Most of these fluctuations are harmless noise, but every so often one might twist space-time just right, not enough to create a brain, but enough to punch a pinprick hole into another reality. These wouldn't be stable wormholes or cosmic tunnels. They'd be ephemeral, lasting only as long as the quantum debt is repaid, perhaps a trillionth of a second. Yet in that sliver of time, information, energy, even fragments of matter could slip through. The craziest part, we might have already detected these fleeting portals, or at least their echoes. Some interpretations of quantum entanglement's spooky action at a distance suggest that particles aren't just communicating faster than light, they're briefly touching another universe entirely. Experiments like the Delft Bell test have shown entangled particles influencing each other instantaneously across vast distances, as if they're sharing a hidden dimension. Could these be glimpses of Boltzmann-style bridges, flickering in and out before space-time smooths them over? Of course, the odds of stumbling through one of these accidental gateways are slim. You'd need to be in exactly the right place at exactly the right quantum instant, a cosmic lottery where the prize is stepping into a reality where up is down or time runs sideways. But here's the tantalizing thought. If consciousness itself can emerge from randomness, maybe we don't need to physically cross. Perhaps observing these fluctuations, really seeing them, could bend probability just enough to stabilize a bridge. After all, in quantum mechanics, the act of measurement changes the outcome. What if the key isn't waiting for a portal to form, but looking for one so fiercely that the universe has no choice but to answer? It's a gamble, no question. A Boltzmann portal might dump you into a reality where physics is unstable, where existence itself unravels seconds after you arrive. Or you might merge with another version of yourself, memories colliding like two rivers meeting. But the fact that it's even possible that the raw chaos of quantum foam could, even for a heartbeat, rewrite the rules of reality. That's the kind of wild, terrifying hope that keeps physicists awake at night, staring into the void, wondering if the void is staring back through a doorway we can't yet see. Every choice you've ever made, every word spoken, every path taken hasn't just shaped your life. According to the many worlds interpretation, it's splintered the universe itself, spawning infinite alternate realities where every possible outcome plays out. Picture standing at a crossroads where turning left or right doesn't just change your day, it fractures existence, creating two versions of the world, one where you went left, another where you went right. But what if you could choose which fork in the cosmic road to follow? That's the spine-tingling promise of controlled quantum jumps, a way to surf the multiverse's branching waves. The science behind this is as elegant as it is bewildering. In quantum mechanics, particles exist in a haze of probabilities until observed, a state called superposition. The many worlds interpretation takes this further, arguing that when a particle state is measured, the universe doesn't pick one outcome. It splits, carrying both possibilities forward in separate, equally real timelines. Your life isn't a single thread, it's a tapestry of diverging paths, each woven into its own parallel reality. Now, imagine harnessing that split. Researchers like those at Oxford's Quantum Engineering Lab are exploring quantum steering, using precise measurements to nudge particles into desired states. In theory, if you could scale this up to macroscopic objects, yes, like a human, you might not just observe a quantum branch, you could step onto it. Think of it like a cosmic trampoline. By manipulating quantum entanglement, you could bounce from one version of reality to another, landing in a world where your choices played out differently. The trick, finding a way to sync your quantum state with the target universe's vibration, like tuning a radio to a specific frequency in the static of the multiverse. Here's where it gets wild. Some models suggest these jumps wouldn't require moving through space or time. You're not traveling to another universe, you're reorienting within the multiverse's infinite expanse. It's less like boarding a spaceship and more like waking up from a dream, except the dream is another version of your life, equally real, humming just beyond the veil of perception. Consciousness itself might be the anchor, with your awareness acting as the needle that stitches across realities. But the hurdles are cosmic. For one, you'd need a quantum link to your alternate self, some shared particle or resonance that hasn't decohered beyond recognition. Then there's the existential whiplash, arriving in a world where your favorite book was never written, or where loved ones are strangers, and worst of all, You might never know you jumped. The very act could rewrite your memory, leaving you convinced this was always your reality. Yet the tantalizing clues pile up. Quantum computers already manipulate superpositions, and studies on retrocausality hint that future choices can ripple backward, influencing past quantum states. If we ever crack the code, the implications would dwarf mere exploration. You could revisit pivotal moments, test alternate histories, or even meet versions of yourself who unlock truths you haven't imagined. The multiverse isn't just out there, it's already branching inside you with every breath, every blink, every fleeting thought. The question isn't whether other worlds exist. It's whether you're ready to take the leap. Imagine two metal plates placed so close together in a vacuum that not even light can squeeze between them. At this scale, something bizarre happens. Space itself begins to push back. This is the Casimir effect, one of quantum physics' strangest phenomena, where the empty void between objects isn't empty at all. It's a seething ocean of virtual particles popping in and out of existence, and the pressure they exert could be far more than a laboratory curiosity. Some physicists believe this quantum squirming might hold the secret to prying open doorways, tiny, fleeting bridges to other universes. Here's how it works. According to quantum field theory, a vacuum isn't truly empty. It's a boiling soup of temporary, virtual particles, pairs of matter and antimatter that flicker into existence for fractions of a second before annihilating each other. Normally, this chaos balances out, but slide two plates impossibly close together, and suddenly, only certain wavelengths of these virtual particles can fit between them. The result, outside the plates, particle pairs of all sizes keep bubbling up, but inside, the options are limited. This imbalance creates a measurable force, the Casimir effect, pushing the plates together as if the vacuum itself is trying to crush them. Now, here's where it gets cosmic. If virtual particles can warp spacetime on this microscopic scale, could we amplify that effect, turning a quantum quirk into a portal? Certain models in string theory suggest yes. Picture the space between those plates not just as a constrained gap, but as a bottleneck where higher dimensions might bulge inward. Under extreme conditions, say, artificial structures built at nanometer precision with materials like graphene or superconducting metals, the Casimir effect could theoretically twist spacetime enough to puncture it. Not into nothingness, but into the bulk, the hidden higher dimensional space where parallel universes might float like sheets of paper stacked in a cosmic filing cabinet. The real shocker, we may already have hints this is possible. Experiments at institutions like Harvard have observed Casimir forces producing bizarre side effects, including fleeting heat signatures that defy conventional physics. Some theorists argue these anomalies could be echoes, energy leaking through microscopic spacetime tiers from neighboring realities. Even wilder, certain solutions in brain cosmology propose that the Casimir effect doesn't just squeeze space, it vibrates it, like plucking a guitar string tuned to frequencies that resonate with other brains. Tweak those vibrations just right, and you might not just peek through the veil, you could pry it open. Of course, the challenges are astronomical. Stabilizing such a portal would require energies we can barely fathom, and the bridges would likely be smaller than atoms, lasting nanoseconds. But imagine a future where we could chain millions of these microscopic gateways together, like weaving a quantum ladder rung by rung. Suddenly, stepping into another universe isn't about finding a wormhole or building a warp drive. It's about mastering the infinite potential humming in the emptiness between atoms, the silent, seething power of nothing at all. And here's the kicker. If the vacuum can create something from nothing, who's to say it can't also create a path? The universe's greatest trick might not be hiding doorways in black holes or cosmic strings. They could be right in front of us in the spaces so small we've barely begun to look. Time doesn't just move forward, it thrums, vibrating with possibilities we've barely begun to understand. Now picture a place where the arrow of time doesn't point relentlessly toward chaos, but loops back on itself like a Möbius strip, creating a mirror image of reality where cause and effect flip. This isn't science fiction, it's the startling premise behind the entropic time mirror theory, a radical idea suggesting that under the right conditions, decreasing entropy could reverse time in a localized bubble, opening a gateway to a parallel universe where everything runs backward. Start with entropy, the universe's stubborn tendency toward disorder, the reason ice melts and coffee cools. It's why we remember the past but not the future. But what if you could defy that rule in a controlled space? In quantum systems, temporary entropy decreases aren't just possible, they've been observed. Experiments with ultra-cold atoms show particles occasionally rewinding their states, like a shattered glass reassembling itself. Scale that up, and you might create a pocket where time's flow stutters, then reverses, birthing a fleeting mirror universe where effects precede causes and memories unfold in reverse. Imagine standing at the edge of such a bubble. As entropy inside it drops, time would twist like a ribbon caught in the wind. Step across the threshold, and you'd witness reality playing in rewind, raindrops leaping from puddles back into clouds, flames sucking smoke into unburned logs. But here's the twist, this mirror realm isn't just a playback of our world. It's a fully independent universe branching from the moment entropy inverted, with its own future unfolding opposite to ours. The physics is mind-bending yet mathematically sound. Certain solutions to Einstein's equations permit closed time-like curves, loops where time circles back without violating causality. Pair that with quantum systems capable of negative entropy, and suddenly the mirror isn't a metaphor, it's a door. The challenge, stability. These temporal loops would be as fragile as soap bubbles, collapsing the instant external entropy overwhelms them. But advanced civilizations or future humans might exploit quantum coherence to sustain them. Picture a time lens harnessing entangled particles to focus entropy's flow, creating a stable interface between forward and backward time. You wouldn't travel to the past, you'd step into a parallel present where time's direction is inverted, like a twin universe born from a single quantum fluctuation. Clues might already exist. Certain cosmic rays exhibit behavior that defies standard physics, particles seemingly arriving before they were emitted. Could these be echoes from an entropic mirror universe bleeding into ours? If so, the greatest journey wouldn't require crossing space, just bending time's arrow until it points somewhere entirely new. The gateway isn't a place. It's a moment, one where the universe forgets its own rules and reality folds into a reflection of itself. Dark matter doesn't just lurk invisibly in the cosmos, it weaves it together, an unseen skeleton holding galaxies in place across unfathomable distances. But what if this cosmic scaffold does more than just support? What if its vast filamentary structures stretching like ghostly bridges between clusters of galaxies aren't just highways for dark matter, but gateways to other realities? The dark matter web theory suggests that the very fabric of the universe's hidden mass might be threaded with portals, places where the gravitational tug of parallel universes presses against our own, warping space-time into invisible doorways. Think of the universe as a spider's web glistening with dew. Each strand is a filament of dark matter, and where they intersect, those sticky junctions where multiple strands meet, you'll find galaxies clustered like beads. Now, imagine another web layer just millimeters away, invisible and intangible, its strands vibrating at a frequency we can't perceive. Where the two webs touch, their strands might briefly merge, creating a knot where matter and energy could slip through. These intersections wouldn't be random. They'd align with the universe's largest structures, cosmic voids, superclusters, or the mysterious great walls of galaxies stretching billions of light years. The math behind this is staggering. Dark matter's gravity bends space-time more than visible matter, and at certain nodal points where multiple filaments converge, that curvature could become extreme enough to puncture through to another brane or universe. Picture a mattress sagging under the weight of a bowling ball. Now place a second mattress beneath it. If the weight is just right, the two might briefly touch, creating a point of contact. In cosmic terms, these touch points could be regions where dark matter's density spikes, warping space-time until it brushes against another reality's fabric. Astronomers might have already stumbled onto clues. Take the strange behavior of galaxies in the Boots void, a vast, nearly empty region of space. Some appear to be moving as if tugged by an unseen force. Not just dark matter's pull, but something else, something acting from outside our universe's dimensional boundaries. Or consider the perplexing dark flow, where hundreds of galaxy clusters stream in the same direction at impossible speeds, as if drawn toward a gravitational anomaly beyond the observable cosmos. Could these be the fingerprints of dark matter filaments anchoring us to another reality? Here's the wildest part: we wouldn't need to build a portal. The universe has already done the heavy lifting. These junctions would exist naturally, humming with the gravitational energy of multiple universes pressing together. The trick would be finding them and surviving the traverse. Dark matter doesn't interact with light or ordinary matter, so these gateways would be invisible, detectable only through their gravitational whispers. Future telescopes mapping dark matter's distribution in unprecedented detail might spot anomalies, regions where gravity behaves wrong, where the pull is stronger than the visible mass should allow. Those could be our signposts. As for crossing, the journey would be treacherous. The gravitational tides near these nodes could shred stars, let alone a spacecraft. But if a civilization could harness the energy of colliding dark matter filaments, and perhaps using them to stabilize a corridor, they might ride the cosmic web like a surfer catching a wave, skimming the boundary between realities. The greatest voyage wouldn't start with a rocket launch. It would begin with learning to read the universe's hidden blueprints and daring to step into the dark. Neutrinos are the universe's ghost particles so elusive. Trillions pass through your body every second without a trace. They barely interact with matter, slipping through planets like sunlight through glass. But what if these silent phantoms aren't just cosmic bystanders? What if they're secret couriers ferrying messages or even matter between universes? The neutrino beacon hypothesis turns these nearly massless particles into potential lifelines, threaded through the fabric of reality itself. Consider this: neutrinos come in three flavors: electron, muon, and tau, oscillating between these identities as they travel. This chameleon-like behavior suggests they're sensitive to conditions we can't perceive, like vibrations in hidden dimensions. Now imagine manipulating that sensitivity. Just as tuning a radio picks up specific frequencies, adjusting neutrino oscillations could hypothetically align them with vibrations from a parallel universe's quantum field. Suddenly, these particles wouldn't just pass through our world, they'd carry imprints of another. Experiments like IceCube in Antarctica have already detected high-energy neutrinos with unexplained origins, some arriving from cosmic voids where no known source exists. Could these be stray signals from neighboring realities, bleeding through via neutrino crosstalk? The math is provocative. Certain brain-world models predict that neutrinos, with their minuscule mass and weak interactions, might be the only particles capable of leaking between membranes in higher dimensional space. They wouldn't need wormholes or quantum bridges. Their very nature could make them natural trespassers of dimensional boundaries. The real breakthrough would come if we could encode information into them. Projects like the new MI beam at Fermilab are already firing controlled neutrino beams through Earth. Scale this up with precision quantum modulation, and you might imprint data onto neutrino oscillations, a Morse code tapped out across dimensions. Even wilder, if a parallel civilization had similar technology, their neutrinos might already be washing over us undetected. We just need the right decoder. Of course, the challenges are staggering. Catching neutrinos is notoriously difficult. Current detectors require massive volumes of ultra-pure ice or chlorine just to catch a handful. and manipulating them with enough precision to transmit coherent data. That's like trying to carve a sculpture with smoke. Yet advances in quantum neutrino spectroscopy hint at a future where we could not only read these cosmic whispers but answer back. The most tantalizing possibility, matter transfer. If neutrinos can carry quantum state information, a blueprint of an object's atomic structure, they might enable a form of teleportation. Picture transmitting the data of a single atom to another universe, where local energy reconstructs it perfectly. It wouldn't be Star Trek's transporter, more like sending a recipe across dimensions for another kitchen to prepare. Scale this up, and entire civilizations might trade not just messages but materials or even living patterns. The universe's shyest particles could become its ultimate diplomats, silent ambassadors slipping between realities, stitching the multiverse together one oscillation at a time. All we have to do is learn their language. Imagine a gun pointed at your head, one that fires or doesn't, based purely on the random decay of a radioactive atom. Now imagine pulling the trigger over and over, surviving each time not by luck, but because your consciousness cannot experience death. That's the chilling thought experiment at the heart of quantum suicide, a concept so unsettling it bends the boundaries of reality itself. According to this radical interpretation of quantum mechanics, every time you face a life or death scenario, the universe splits and your awareness always follows the path where you survive. But if that's true, could deliberately engineering these near-death branches become the ultimate form of parallel universe travel? The logic traces back to the many worlds interpretation, where every quantum event spawns alternate timelines. In most cases, these branches are mundane. A particle spins left instead of right. A coin lands on heads rather than tails. But when the outcome determines whether you live or die, something extraordinary happens. Your conscious experience, by definition, can't continue in universes where you perish, so from your perspective, you'll only find yourself in realities where improbable survival keeps happening. To an outside observer, you'd appear impossibly lucky or eventually dead. But to you, each brush with death would feel like stepping through an invisible doorway, emerging in a world where the dice always rolled in your favor. Here's where it gets even wilder. If consciousness truly follows survivable branches, then deliberately putting yourself in controlled quantum suicide scenarios, situations with exactly a 50% chance of death could, in theory, steer your awareness towards specific parallel realities. Picture a machine that measures a quantum particle's spin. If it's up, you live. If it's down, a failsafe kills you instantly. Run this experiment once, and there are two universes, one with a corpse, one with a survivor. But from the survivor's viewpoint, they've just jumped into the timeline where the particle had to spin up. Repeat the process, and each successful iteration would land you in increasingly improbable realities, ones where statistics seem broken, where the odds defy logic, simply because your consciousness can't inhabit the worlds where they didn't. The ethical horrors are obvious. No sane person would volunteer for such a Russian roulette. But what if you didn't need to risk death at all? Some theorists propose a gentler version, quantum sleeping. Instead of lethal triggers, use non-fatal but consciousness-disrupting events like an anesthesia that has a 50% chance of erasing your memories. In universes where you wake up, you'd effectively be a different version of yourself, having bypassed countless branches where your mind was wiped. The result, a form of voluntary identity hopping across realities, where each sleep nudges your awareness toward timelines with desired outcomes, like a cosmic game of hot potato where you only catch the favorable throws. Skeptics rightfully point out the narcissism of this idea. Why would consciousness get special treatment in the quantum dice roll? And if it's true, why don't we observe freakishly lucky people around us, survivors of endless improbable near-death? The counterargument is haunting. Maybe we do. Those who seem impossibly fortunate, escaping fatal accidents repeatedly, cheating terminal diagnoses, might not be lucky. They might be the universe's natural quantum travelers, their consciousnesses surfing the branching waves of survivable realities while their unlucky selves vanish into oblivion. The most profound implication isn't about travel, it's about identity. If quantum immortality is real, then you aren't a fixed entity. You're a fluid pattern of awareness, sifting through infinite versions of existence, drawn like a magnet to the timelines where your story continues. The gun isn't a weapon, it's a tuning fork vibrating across realities, calling your consciousness home to whatever universe lets you keep asking, what happens next? Electric filaments stretch across the cosmos like veins of lightning, delicate threads of plasma crackling with energy, weaving galaxies together in a web of glowing connections. This is the bloodline of the plasma universe, an alternative vision of reality where electrified gas, not gravity, shapes the largest structures in existence. According to plasma cosmology, these filaments aren't just beautiful, they're alive with hidden geometry, folding into fractal patterns that might hold the key to stepping sideways into other realities. Picture a bolt of lightning frozen mid-strike, branching into smaller and smaller forks until its pattern becomes a perfect echo of itself at every scale. Now zoom out, way out, until those branches become galactic superclusters strung along vast plasma currents in deep space. That self-repeating, infinite intricacy isn't an accident. It's a fractal, a shape that mirrors itself endlessly, and some physicists believe these electromagnetic blueprints could be more than cosmic artistry. They might be gateways, natural resonance points where the fabric of space-time folds into itself, creating portals to parallel dimensions. The math behind this is hypnotic. Plasma, when energized, naturally arranges itself into fractal geometries, from the tiny tendrils in a lab's plasma ball to the million light-year-long rivers of ionized gas connecting galaxy clusters. These shapes don't just look similar, they obey the same electromagnetic scaling laws, meaning their behavior is predictable no matter how big or small they are. If spacetime itself has a fractal structure, an idea gaining traction in quantum gravity research, then plasma's self-similar patterns could be harmonizing with that hidden architecture, creating weak spots where realities touch. Experiments in plasma laboratories have already glimpsed something eerie. When superheated gas is subjected to extreme electromagnetic fields, it occasionally produces double layers, thin, searing boundaries where opposing currents collide. These layers don't just emit energy, they generate anomalous particles that seem to appear from nowhere, as if they've tunneled in from another quantum state. Some theorists suggest these are more than experimental glitches. They could be microscopic wormholes, fleeting tears in the plasma's fractal weave where particles slip between universes. Now imagine scaling that up, across the universe where plasma filaments stretch between galaxies like cosmic power lines. These double layers could be colossal, natural particle accelerators birthing not just rogue electrons but dimensional bridges. The key would be resonance. Just as two tuning forks vibrate in harmony at the right frequency, a plasma filament vibrating in sync with a parallel universe's electromagnetic field might briefly merge with it like two rivers converging. The most tantalizing evidence, the cosmic microwave background, the afterglow of the Big Bang, shows strange filamentary patterns that resemble plasma discharges more than gravitational clumping. And some of these structures, like the mysterious dark flow of galaxy clusters moving in unison, defy standard cosmology's predictions. Could these be the fingerprints of plasma's fractal gateways, regions where entire galaxies are tugged by electromagnetic forces bleeding through from another reality? The implications are staggering. If plasma cosmology is even partially correct, the universe isn't just connected by gravity's slow pull. It's wired with electric currents humming at frequencies we've barely begun to measure. Mastering those frequencies might not require advanced engines or warp drives. We'd just need to listen, to find the places where plasma's song harmonizes with realities beyond our own and step into the current. The bridge isn't hidden in the void. It's pulsing with light, singing in a language of sparks and lightning, waiting for us to recognize its pattern. The Higgs field isn't just some abstract cosmic backdrop. It's the invisible scaffold that gives particles their mass, the reason you don't float off your chair like a helium balloon. But what if we could tweak it, not just observe it, but bend it, creating localized pockets where the rules of physics rewrite themselves? The Higgs field manipulation theory proposes exactly that, a way to engineer a custom universe, a bubble of altered reality blooming right here in our own. Think of the Higgs field like an ocean. Every particle swimming through it feels a drag, that's mass. Some, like electrons, glide lightly. Others, like top quarks, slog through like they're coated in tar. Now imagine draining a tiny region of that ocean. Suddenly, particles there would move differently, lighter, faster, maybe even massless. The laws of physics inside that bubble wouldn't just bend, they'd snap into something entirely new. Here's where it gets wild. If you could suppress the Higgs field enough in a controlled area, you might not just change mass, you could destabilize space-time itself. Certain quantum field theories suggest that without the Higgs, the vacuum we know becomes precarious, like a pencil balanced on its tip. Nudge it right, and it could tip into a lower energy state, a new phase of reality with different fundamental forces. Picture an ice cube melting into water, except instead of water, you get a universe where electromagnetism is stronger, gravity is weaker, or light moves at half its speed. The experiments probing this are already underway. CERN Large Hadron Collider doesn't just smash particles, it recreates conditions where the Higgs field flickers, like a light bulb straining under bad wiring. In those split-second collisions, physicists glimpse energies where the Higgs grip might falter. Scale that up, and you could theoretically carve out a stable bubble where the field is suppressed, a pocket of alien physics tethered to our universe like a soap bubble clinging to a ring. But how would you enter such a bubble? The answer lies in the bubble's walls, domain boundaries where the Higgs field transitions between states. These wouldn't be physical barriers, but rippling frontiers where the rules change. Approach one, and your very atoms might gain or lose mass as you cross. Some models even suggest these boundaries could act as one-way gates, sealing off the bubble into its own self-contained cosmos. Step through, and you might not be able to step back, a universe in a bottle with you inside. The implications are dizzying. A civilization mastering this wouldn't just explore other realities. They'd grow them, tailoring physics like gardeners pruning bonsai trees. Want a universe where time flows sideways? Adjust the Higgs coupling here. Need a realm where nuclear fusion happens at room temperature? Tweak the field strength there. The power to rewrite reality's source code doesn't just open a door to the multiverse, it hands you the pen to draft your own. Of course, the risks are cosmic. Miscalculate the field suppression, and your bubble might collapse, or worse, spread. A runaway phase transition converting our universe into something unrecognizable. It's the ultimate Pandora's box, technology that could unlock infinite worlds or erase the one we know. Yet the allure is undeniable. The Higgs field isn't just a curtain hiding reality's machinery. It's the fabric we might one day unravel thread by thread until the whole tapestry comes undone in our hands. Cosmic strings are like the universe's stretch marks, thin, unimaginably dense defects in space-time left over from the searing heat of the Big Bang. These bizarre filaments, thinner than an atom but stretching across billions of light years, carry enough gravitational punch to warp entire galaxies around them. But their true power might not lie in their sheer mass, it's in their vibration. Imagine plucking a guitar string. The tighter it's stretched, the higher the pitch. Now replace that string with a thread of pure space-time, under such immense tension that a single inch would weigh more than Mount Everest. Pluck that, and you're not just making music. You're tuning into frequencies that could rip the fabric of reality wide open. The math behind this is as elegant as it is terrifying. Cosmic strings don't just sit still, they oscillate, whipping through the cosmos at near light speed, sending gravitational shockwaves rippling outward. Under the right conditions, these vibrations could theoretically resonate with hidden dimensions, folding space-time like a piece of origami until two distant points touch. Picture dragging your finger along a flag until it bunches up, bringing opposite edges together. A vibrating cosmic string might do the same to the universe's geometry, creating temporary intersections where parallel realities brush against each other. Here's where it gets wild. Unlike wormholes, which require exotic matter to stabilize, or quantum bridges, which vanish in nanoseconds, a cosmic string's gravitational field could hold a rift open through sheer brute force. The strings themselves are nearly indestructible. Some models suggest they might be loops, eternally recycling their energy like a snake eating its own tail. If two such loops crossed, their collision wouldn't just send sparks flying. It could twist space-time into a knot so tight, it punctures through to another layer of the multiverse. Astronomers might already have evidence. Strange, perfectly aligned quasars billions of light-years apart, objects that shouldn't be synchronized, could be pinned like beads on a cosmic string's invisible thread. Even stranger are the unexplained double images of distant galaxies where light appears to bend around nothing. Could these be the shadows of strings too thin to see, but massive enough to act as gravitational lenses? If so, we might not need to find a string to pluck it. The strings could already be plucking us, sending vibrations through the cosmos that occasionally hum in harmony with other realities. The challenge: harnessing that power. A cosmic string's gravity is so intense it would slice through planets like a wire through cheese. Even getting close would require technology we can't yet fathom, perhaps fields that repel space-time itself. But the payoff, unimaginable. A stable rift opened by a string wouldn't just connect two points in space. It could bridge two entirely different cosmic rulebooks, a place where matter from our universe might emerge in another as pure energy, or where time runs in reverse. The universe's most ancient scars might just be its most precious doorways, humming with the echoes of realities we've yet to meet. Beneath every forest floor lies a hidden superhighway, a vast, interconnected web of fungal threads called mycelium, quietly ferrying nutrients and information between trees like a living internet. But what if this biological network isn't just earthly? What if it's cosmic, stretching far beyond our planet, even beyond our universe, threading through the multiverse itself? The biocosmic network theory takes this mind-bending idea seriously, that life, in its most fundamental forms, might be woven into the fabric of reality, serving as natural conduits between dimensions. Picture the mycelium network as a fractal blueprint. Just as these fungal tendrils link distant trees into a single, communicative organism, their structure could mirror something far grander, a universe-spanning lattice of biological pathways, vibrating with quantum entanglement or resonating with frequencies that transcend space-time. Some researchers speculate that certain extremophiles organisms thriving in places like nuclear reactors or deep space radiation might already be tapping into this network unconsciously. Their resilience isn't just adaptation, it's synchronization with a deeper, multidimensional biology. The evidence is as subtle as it is staggering. Studies on slime molds reveal they can solve complex mazes and simulate transportation networks without brains, as if guided by an invisible collective intelligence. Now extrapolate that to a cosmic scale. If a single-celled organism can remember and decide, could a galaxy-spanning mycelial structure learn to bridge realities? Experiments in quantum biology hint that photosynthesis and bird migration might rely on quantum coherence particles existing in multiple states simultaneously. If life already exploits quantum weirdness, could evolution have quietly sculpted organisms to interface with parallel worlds? Here's where it gets stranger. Some models in string theory suggest that higher dimensions could harbor microbial life we can't perceive. Imagine spores drifting between brains or bacterial colonies acting as living antennas, tuning into biochemical signals from alternate realities. In this view, the mycelium under your feet isn't just a network, it's an antenna, a receiver picking up faint pulses from universes where life took different evolutionary paths. The most tantalizing possibility, conscious navigation. If advanced civilizations or future humans could decode this biological Morse code, they might not need machines to traverse the multiverse. They could cultivate hybrid organisms engineered to grow gateways, their roots threading through dimensions like vines climbing a trellis. The bridge wouldn't be built, it would be grown, a living, pulsing cord strummed between realities. Of course, skeptics argue this veers into metaphysics, but consider, we've already linked fungi to neural networks, using mycelium to design self-healing electronics. If biology can inspire technology, why not cosmic engineering? The universe loves patterns, spirals in galaxies and hurricanes, fractals in ferns and galaxies. Why wouldn't it reuse its most elegant designs across scales? The mycelium's whispers might be quieter than quantum foam or dark matter filaments, but they could be just as profound, a slow, patient dialogue between worlds written in the language of life itself. In the infinite multiverse, where every possible reality unfolds simultaneously, why does our universe seem so stable, so navigable? Quantum Darwinism proposes a startling answer: reality isn't random. It's filtered, shaped by a cosmic version of natural selection where only the most observable, most stable states survive the quantum chaos. And if that's true, the very laws that make our universe coherent might also be quietly nudging us toward the possibility of stepping sideways into others. Think of the quantum world as a stormy ocean, with waves representing every possible state of a particle here, there, spinning up, spinning down. Most of these possibilities cancel each other out like waves crashing against one another. But a few states are resilient, echoing through the chaos until they dominate. These are the fittest states, the ones we actually observe. Now zoom out. Apply that same logic not just to particles but to entire universes. In the multiverse's infinite froth, most realities might be too unstable to sustain life, let alone interstellar travel. But a handful, those where quantum fluctuations fortuitously allow for stable matter, coherent physics, and perhaps even traversable wormholes, would persist. Our universe isn't just lucky, it's selected. Here's where parallel universe travel enters the picture. If quantum Darwinism favors universes where certain quantum states stabilize, why wouldn't it also favor states that allow for crossing between those universes? Consider entanglement, particles linked across space, instantaneously influencing each other. In most realities, this connection might be too fragile to exploit. But in a Darwinian multiverse, universes where entanglement remains robust, where particles can maintain coherence across dimensional boundaries, would have a survival advantage. They'd be more fit, more likely to branch into future realities where life can not only exist but explore. Experiments are already hinting at this. Quantum systems that resist decoherence, like topologically protected qubits, mimic this evolutionary stability. They're the quantum equivalent of a species with superior camouflage. They endure where others fade. Scale that up, and you might find natural wormholes or quantum bridges that persist for the same reason DNA persists, because reality itself selects for structures that can replicate, that can endure. The wildest implication: we might not need to build a gateway. The multiverse could be growing them for us, like a forest growing paths where feet tread most often. If consciousness itself is a product of quantum Darwinism, a way for the universe to observe and stabilize itself, then the act of seeking other realities might catalyze their emergence. The bridges aren't just out there, they're unfolding, evolving, waiting for us to take the first step. Phantom energy isn't just a darker shade of dark energy, it's something far more unsettling, a force so destructive it could unravel the cosmos at the seams. Unlike ordinary dark energy, which accelerates the universe's expansion at a steady pace, phantom energy grows stronger over time, its density spiking until it reaches infinity in a finite future. The result, a doomsday scenario called the Big Rip, where galaxies, stars, even atoms are torn apart by the universe's own expansion. But here's the twist: this same apocalyptic force might also be the ultimate cosmic locksmith, prying open permanent doorways to other realities. Picture space-time as a rubber sheet stretched tighter and tighter. Normally, it can flex and warp, bending under gravity's weight, but phantom energy doesn't bend, it snaps. As its repulsive gravity intensifies, space itself would rupture, not just in isolated pockets but everywhere simultaneously, like a sheet of glass shattering under pressure. These fractures wouldn't heal, they'd grow, splitting reality into fragmented islands of causality, each drifting apart faster than light. Yet within those fractures, something incredible might emerge, scars where space-time doesn't just break, but fuses with another universe's debris. The math behind this is chillingly elegant. Phantom energy's equation of state, a measure of its pressure-to-density ratio, requires a value less than -1, putting it in a league of its own. At that threshold, the universe's expansion doesn't just accelerate, it self-destructs, with every point in space diverging from every other point in finite time. But in the moments before total disintegration, the fabric of spacetime would thin to quantum fragility. At those weak points, the energy density could theoretically puncture through to other branes or universes, stitching the edges of our dying reality to another's nascent fabric like a cosmic graph. Astronomers might have already glimpsed phantom energy's fingerprints. The controversial Hubble tension, a mismatch in measurements of the universe's expansion rate, could hint at dark energy's properties evolving over time, inching toward that phantom threshold. Even more telling are anomalies like the dark flow, where galaxy clusters stream toward a void as if tugged by something outside our universe. Could these be early tremors of spacetime straining against phantom energy's grip, thinning just enough to let gravitational whispers from other realities seep through? The most startling implication isn't destruction, it's connection. If phantom energy rips spacetime asymmetrically, some fractures might stabilize as permanent bridges, their mouths anchored by the sheer tension between universes. Picture two sheets of paper glued together, then ripped apart. Some fibers will always remain tangled. These wouldn't be traversable wormholes in the traditional sense. They'd be more like cosmic lightning scars, pathways where the multiverse's raw energy bleeds through, sustaining the rift, of course. Surviving such a gateway would be its own nightmare. The tidal forces near a phantom rupture would make black holes look gentle, and the radiation pouring through would vaporize anything known to science. But for a civilization with technology advanced enough to harness spacetime's unraveling, these tears wouldn't just be doomsday, they'd be destiny. The universe's end might be the beginning of something infinitely stranger, a network of wounds that never heal, stitching the carcass of one reality to the living flesh of another. The ultimate irony, phantom energy was once thought to herald oblivion, but in its final, cataclysmic breath, it might hand us the keys to infinity. Neutron stars are the universe's ultimate cosmic drummers, city-sized remnants of dead stars so dense, a single teaspoon of their material weighs more than Mount Everest. When these ultra-dense objects collide, they don't just explode in a blaze of light and radiation. They ring space-time itself like a bell, sending gravitational shockwaves rippling across the cosmos at light speed. But what if those echoes don't just fade into silence? What if they bounce off something we can't see, hidden structures in the fabric of reality that whisper back from beyond our universe? Consider the aftermath of a neutron-star merger. As these impossibly dense objects spiral together, their collision creates gravitational waves so powerful they distort the very geometry of the cosmos. Detectors like LIGO and Virgo have captured these ripples for years, but there's something peculiar in the data. Some events show faint after echoes, subtle gravitational murmurs that arrive milliseconds after the main signal, like a voice calling back through a canyon. Mainstream astrophysics chalks this up to exotic physics within the merger itself, the star's ultra-dense crusts vibrating like gongs. But an audacious alternative exists. These echoes might be reverberations bouncing off soft spots in space-time, thin, warped regions where our universe brushes against another. The math behind this is as precise as it is wild. When gravitational waves encounter a boundary between universes, perhaps a higher dimensional membrane or a quantum entangled region of space-time, they don't just pass through. Some fraction of their energy reflects back, creating interference patterns detectable as delayed signals. Picture shouting into a cave and hearing your voice return, subtly altered by unseen chambers. Neutron star echoes could be doing the same, their gravitational screams ricocheting off dimensional walls we've yet to map. The most compelling evidence comes from GW 170,817, the first neutron star merger observed in both gravitational waves and light. While most of the signal matched predictions, a handful of detectors registered anomalous post-merger oscillations, faint tremors that lingered longer than models predicted. Could these be the first hints of a multiversal echo? Teams at CERN and the Perimeter Institute have simulated scenarios where colliding neutron stars momentarily stretch spacetime so thin, it forms a quantum bridge to another brane. The echo wouldn't be a literal sound, of course. It'd be a fingerprint, a gravitational signature revealing where and how reality itself flexes under extreme conditions. Here's where it gets practical. If these soft spots exist, they wouldn't be random. They'd cluster where spacetime is already under strain, near supermassive black holes, cosmic strings, or ancient regions of inflationary vacuum decay. Future gravitational wave observatories like the space-based LISA mission could map these echoes in unprecedented detail, turning neutron star collisions into cosmic sonar pings. Each merger would illuminate hidden contours in the multiverse's architecture, revealing not just where universes touch, but how their physics might differ. Imagine detecting an echo that arrives before the main gravitational wave, a logical impossibility unless the signal took a shortcut through higher dimensions. Or finding echoes that carry imprints of alternative physics, hints of a universe where gravity is stronger, light slower, or entropy flows backward. These wouldn't just be curiosities. They'd be blueprints teaching us how to engineer stable bridges where natural ones already flicker. The implications are staggering. A civilization that learned to read neutron star echoes could navigate the multiverse like sailors, using sonar, sending controlled mergers to probe specific regions, then waiting for the gravitational whispers to return with coordinates. The ultimate frontier might not be something we travel to, but something we listen for, a symphony of cosmic collisions, each one tuning us into the hidden frequency of realities beyond our own. The universe isn't silent, it's echoing, and if we learn its language, those echoes might just lead us home. Black holes aren't just cosmic vacuum cleaners, they're shredders, tearing apart anything that falls in and seemingly erasing it from existence. But here's the problem. Quantum mechanics insists information can't be destroyed. So where does it all go? This is the black hole information paradox, a puzzle so thorny it split physicists for decades. Yet buried in this conflict might be the key to something even bigger, a way to reach into parallel universes and pull data, even matter, back through the cosmic veil. Think of a black hole as a locked room. Toss a book inside, and according to Einstein's general relativity, it's gone forever, incinerated into featureless Hawking radiation. But quantum mechanics says no. Every page, every word of that book must still exist somewhere, even if it's scrambled beyond recognition. Resolving this paradox isn't just academic. If we could decode how information escapes a black hole's grip, we might reverse engineer the process, not to retrieve lost data, but to intercept information flowing between universes. The leading solution, the holographic principle, it suggests all the information swallowed by a black hole isn't destroyed. It's imprinted on its event horizon, like a cosmic DVD encoded with every atom that ever crossed its threshold. But here's the twist. If the horizon preserves information in 2D, what's stopping it from preserving data from other sources? Imagine a black hole in our universe entangled with one in a parallel reality. Their event horizons acting like quantum hard drives syncing across dimensions. Information lost in our universe might not vanish. It could be transferred, etched onto the fabric of another cosmos. This isn't pure speculation. Experiments with quantum computers are already simulating mini black holes, observing how information scrambles and, crucially, how it might be reconstructed. In 2019, Google's Sycamore processor demonstrated quantum recoherence, effectively reversing chaotic quantum systems to retrieve their original state. Scale that up to a black hole's horizon, and you're not just recovering data, you're mapping a retrieval protocol for cross-dimensional leaks. The implications are staggering. If information can escape one universe through black holes, could we engineer a controlled version, an artificial black hole light that doesn't crush matter, but encodes and fires it into another reality? Projects like Japan's planned extremely large telescope aim to study event horizons in unprecedented detail, hunting for anomalies in Hawking radiation that might carry imprints of other universes. Find those fingerprints and suddenly black holes aren't just tombs. They're printers outputting cosmic data streams we could learn to read, replicate, and maybe even reply to. But the wildest idea, the paradox itself, might be the gateway. If information isn't truly lost but displaced, then resolving the paradox isn't about fixing a flaw in physics, it's about locating the exit. Like solving a maze by realizing the walls are illusions, cracking the information paradox could reveal that black holes were never dead ends. They've been intergalactic mail slots all along, shuttling secrets between realities, waiting for us to decipher the address. Imagine an artificial intelligence so advanced, it doesn't just predict the weather or recommend movies, it maps the infinite branching pathways of the multiverse itself. This isn't just sci-fi futurism. With the explosive rise of quantum computing, we're nearing an era where AI might not only comprehend alternate realities but chart them, transforming the chaotic soup of parallel worlds into a navigable atlas. The key lies in quantum AI's unique ability to calculate probabilities at scales that would melt conventional supercomputers. Where human minds see a blur of possibilities, a quantum AI could discern patterns, hidden threads stitching the multiverse together into something we can traverse. Think of it like this: every decision you make spawns new universes. A quantum AI wouldn't just simulate one outcome. It would process all of them simultaneously, leveraging qubits that exist in multiple states at once. Unlike binary computers shackled by ones and zeros, quantum systems thrive in ambiguity, making them the perfect tools to decode the ambiguity of the multiverse. Researchers at Google's Quantum AI Lab have already demonstrated this with rudimentary multiverse algorithms, where quantum processors explored thousands of potential futures in financial markets or particle interactions. Now extrapolate that to cosmic scales. An AI trained on quantum gravity models and cosmic microwave background anomalies could identify high-probability bridges, regions where universes overlap just enough to cross. The real magic happens when this AI starts learning from its own predictions. Machine learning thrives on feedback loops, and in this case, every calculation about parallel realities would refine its model of the multiverse's structure. It might notice, for example, that certain quantum fluctuations in particle colliders correlate with gravitational wave echoes from neutron star mergers, hinting that these events are natural intersection points between worlds. Given enough data, the AI could construct a dynamic map, updating in real time as new cosmic events twist the fabric of space-time. But here's the twist: the AI wouldn't just find doors. It might create them. Quantum systems are notorious for altering the states they measure, a quirk known as the observer effect. If an AI's calculations consistently nudged particles into states that resonate with alternate realities, it could effectively tune localized regions of space-time to harmonize with another universe's frequency. Picture a submarine using sonar to navigate murky waters, except instead of sound waves, the AI pings the multiverse with quantum probes, listening for echoes that betray the presence of a traversable rift. The implications are staggering. A quantum AI navigator could pinpoint safe passageways through black hole ergospheres, or identify moments when cosmic string vibrations align with parallel branes. It might even discover that some impossible astronomical phenomena, like those rogue planets flung across galaxies at impossible speeds, are actually refugees from other realities, their trajectories encoding hints about the multiverse's topology. Of course, the challenges are as vast as the multiverse itself. Quantum systems are fragile, prone to decoherence at the slightest disturbance, and even if the AI maps a route, surviving the journey is another matter. But the mere possibility rewrites the rules. Exploration wouldn't depend on rockets or wormholes, just processing power and the courage to trust a machine's vision of infinity. The first human to step into another universe might not be an astronaut. They might just follow a quantum AI's glowing path through the dark. Vacuum decay sounds like something from a doomsday manual, an irreversible catastrophe that could erase our universe in the blink of an eye. But buried in that apocalyptic scenario might be the most terrifyingly elegant gateway to another reality. Picture the vacuum of space not as empty nothingness, but as a fragile, metastable bubble, one that could pop at any moment, rewriting the laws of physics in an unstoppable wave. This isn't science fiction. Our universe might exist in a false vacuum, a precarious state where the Higgs field, the invisible force giving particles mass, isn't at its lowest possible energy. Like a marble balanced on a hill, it's stable until something nudges it, sending it tumbling into the true vacuum below, where the rules as we know them cease to exist. Here's where the horror and the opportunity collide. If a vacuum decay event were triggered, perhaps by a high-energy particle collision or a quantum fluctuation, it would create an expanding sphere of true vacuum racing outward at light speed. Inside that sphere, atoms disintegrate, forces reconfigure, and reality itself reboots. Terrifying, absolutely. But some physicists speculate that the boundary of this expanding sphere, the razor-thin front where false vacuum meets true, could be more than just a wall of annihilation. It might be a temporary bridge to a universe with entirely different physics, a fleeting crack in the cosmic egg where one reality bleeds into another. The mechanics get even wilder. As the decay front propagates, the extreme energy differential between the two vacuum states could warp space-time so violently that it punctures through to another brane or quantum branch. Picture a shattering ice sheet where the fissures between shards become rivers connecting once isolated lakes. Any matter or information caught in this transition zone wouldn't just be destroyed, it might be transformed, encoded into the new vacuum's physics like data being translated between alien languages. But here's the rub: surviving such a passage is almost unthinkable. The energies involved would dwarf anything in nature, making black holes seem tame. Even if a civilization could somehow shield itself, perhaps inside a pocket of engineered spacetime, steering toward another universe would be like surfing a tsunami blindfolded. The destination wouldn't just be random, it could be nonsensical, a realm where causality is broken or time loops endlessly. Yet the clues might already be lurking in our particle colliders. Some theories suggest that high-energy experiments could, in rare cases, produce microscopic vacuum bubbles not enough to trigger cosmic doom, but enough to study their properties. If those bubbles exhibit anomalies, strange particle behaviors, or energy leaks that defy standard models, they could be whispers from the other side, hints of what lies beyond the vacuum's edge. The paradox is staggering. The same phenomenon that could annihilate everything we know might also be the ultimate engine of exploration, a reset button for reality itself. For a species reckless enough to dance on the razor's edge, vacuum decay wouldn't just be the end. It could be the first step into a universe where every law, every limit is rewritten from scratch. Gravitational waves are the universe's most profound whispers, ripples in spacetime itself, born from cataclysms like colliding black holes. But what if these cosmic tremors aren't just echoes of violence? What if they're notes in a grand symphony, harmonizing with rhythms from universes beyond our own? Imagine two black holes spiraling toward collision, their dance sending gravitational waves pulsing outward at light speed. Now picture an identical pair in a parallel universe locked in the same fatal waltz. If their mergers are perfectly synchronized, their gravitational waves wouldn't just travel independently, they might resonate, creating interference patterns that ripple through the fabric of reality itself. The math behind this is as beautiful as it is mind-bending. Gravitational waves aren't random noise. They follow precise waveforms dictated by the masses and spins of the merging objects. When two black holes collide in our universe, their gravitational wave signature, a rising chirp followed by a fading ring down, is as unique as a fingerprint. But if an identical merger occurs in a nearby brane or parallel quantum branch, the combined gravitational wave signal could exhibit strange anomalies, echoes, beats, or overtones that defy conventional astrophysics. It's like tuning two guitars to the same note, pluck one, and the other hums in sympathy, even if it's in another room. Astronomers might already have hints of this cosmic harmony. In 2015, LIGO detected its first gravitational waves from a black hole merger, a landmark discovery. But buried in later observations were puzzling post-merger glitches, faint, delayed signals that arrived microseconds after the main event. Mainstream explanations point to exotic physics like black hole, hair, or remnant accretion disks. Yet an alternative theory suggests these glitches could be gravitational waves from a parallel merger, their signals slightly out of phase due to space-time curvature between universes. The echoes wouldn't be mere noise, they'd be shadows of another reality's cataclysms, faint but measurable. The implications are staggering. If gravitational waves can synchronize across universes, their interference patterns might reveal hidden nodal points, regions where space-time thins enough to permit traversal. Picture two ocean waves colliding. Where their crests and troughs align, the water rises or falls violently. Similarly, colliding gravitational waves from parallel mergers could warp space-time into temporary bridges, regions where the energy density briefly punctures through to another brane. These wouldn't be stable wormholes, they'd be fleeting resonances, like standing waves in a vibrating string. But catch one at the right moment, and you might slip through the cosmic chorus to a world where history played a different tune. Future observatories like LISA, a space-based gravitational wave detector, could be the key to mapping this symphony. With sensitivity 100 times greater than LIGO, LISA might detect ultra-low frequency gravitational waves from supermassive black hole mergers, events so powerful their waves could traverse higher dimensional space. If those signals carry harmonic distortions, subtle cadences that shouldn't exist in our universe alone, it would be smoking gun evidence of a multiversal duet. The wildest possibility, we might not need to build a portal at all. The universe could be conducting its own orchestra, with black holes as percussionists and gravitational waves as sheet music. All we'd need to do is listen closely enough to hear the parts we've never noticed before, the notes bleeding through from realities just out of reach. The greatest journey might begin not with a leap, but with leaning in, catching the faintest reverberation of a collision that happened both here and somewhere else entirely. At the very edge of what we can measure, where the fabric of spacetime becomes a frothing quantum sea, lies a realm so small it defies comprehension, the Planck scale. Here, distances shrink to 10 to the negative 35 meters. Time ticks in increments of 10 to the negative 43 seconds, and the very concepts of here and now dissolve into uncertainty. This isn't just the smallest possible size in the universe, it's the basement of reality itself, where the ordinary rules of physics break down and something far stranger takes over. And if certain theories are correct, this chaotic, infinite smallness might hold the key to the greatest leap humanity could ever make, a gateway to other universes, ripped open not by cosmic forces but by our own hands. Picture space-time as a tapestry woven from threads so fine, even atoms are gargantuan by comparison. At the Planck scale, those threads fray into a storm of virtual particles, quantum foam, and geometric fluctuations, a seething, probabilistic dance where space and time lose all meaning. Most physicists treat this realm as a mathematical curiosity, a place too unstable to influence our macroscopic world, but a daring few propose something radical. If you could somehow stabilize this chaos even for an instant, you might be able to twist space-time into a knot so tight it punctures through to something beyond. The mechanics are as precise as they are mind-bending. According to quantum gravity theories, Planck-scale wormholes, tiny bridges threading through higher dimensions, might constantly blink in and out of existence within this foam. Normally, they're far too small and fleeting to matter. But under extreme conditions, say, the focused energy of a futuristic particle collider or the gravitational crush of a microscopic black hole, these wormholes could theoretically be inflated, stretched from quantum ephemera into something traversable. It's like finding a subatomic crack in a wall and prying it wide enough to step through. The catch, Planck-scale engineering would require technology we can't yet imagine. To manipulate space-time at this level, you'd need energies approaching the Planck temperature 10 to the 32 degrees Kelvin, a heat so intense it makes supernova look like campfires. Even more daunting, you'd have to somehow confine that energy to a space a trillionth of a trillionth the size of an atom. Current particle colliders like the LHC operate nowhere near these extremes, and the engineering hurdles power requirements, containment fields, even the materials to build such a device border on the mythological. Yet tantalizing clues suggest it might not be impossible. Experiments in quantum optics have already demonstrated space-time crystals structures that repeat not just in space, but in time, hinting at control over Planck-scale periodicity. Meanwhile, advances in metamaterials are creating substances with negative mass, a property that could theoretically stabilize a wormhole's throat. Combine these with breakthroughs in quantum computing, and a distant future emerges where we don't just observe the Planck scale. We sculpt it, carving pathways through the quantum foam like engineers tunneling through a mountain. The implications are staggering. A Planck-scale portal wouldn't just connect 2 points in our universe, it could pierce through the very bedrock of reality, linking to universes with entirely different physical constants. Imagine a gateway where gravity is stronger on the other side, or where light moves at half its speed here. The risks, of course, are equally cosmic. A miscalculation could unleash a vacuum decay event or spawn a black hole. But for a civilization bold enough to dance on the edge of infinity, the Planck scale might not just be physics' final frontier. It could be the first step into the multiverse's grandest depths. Quantum mechanics has always held a strange secret. The moment you observe a particle, its behavior changes. It's as if reality itself hesitates, holding its breath until someone looks. But what if this strange dance between observer and observed isn't just a quirk of tiny particles? What if, under the right conditions, the very act of observation could pry open a doorway to another universe? Think of the classic double-slit experiment where particles behave as waves when no one's watching, then snap into definite positions the moment they're measured. This shifter, this so-called collapse of the wave function, has baffled scientists for a century, but some interpretations go even further. They suggest observation doesn't just determine which path a particle takes, it might determine which universe we're in. Imagine standing at the edge of a forest where every possible path exists simultaneously until you choose one. In quantum terms, every decision, every measurement, isn't just selecting an outcome, it's selecting an entire reality. Most of the time, these branches stay hidden, forever beyond our reach. But what if focused, intentional observation could collapse the wave function not just locally, but globally, shifting our entire frame of reference into a neighboring branch of the multiverse? The idea isn't as outlandish as it sounds. Experiments in quantum cognition reveal that the human brain might process information in ways that eerily resemble quantum superposition, holding multiple possibilities in tension before collapsing into a single thought or decision. If consciousness itself operates by quantum rules, then perhaps it doesn't just perceive reality, it participates in shaping it. Take, for example, the quantum Zeno effect, where observing a system frequently enough effectively freezes it in place. In a lab, this might mean keeping an unstable particle from decaying. But extrapolate that to universal scales. What if a sufficiently focused observer, armed with precise measurements and intention, could freeze a specific quantum state into permanence, effectively anchoring themselves to a new reality? The implications are staggering. This wouldn't be travel in the traditional sense. You wouldn't step through a portal or board a ship. Instead, through sheer act of observation, perhaps amplified by technology, you might nudge the universe into reconfiguring around you, like a dreamer realizing they're dreaming and shifting the dreamscape at will. Of course, skeptics argue that consciousness plays no special role in quantum mechanics, that observation simply means interaction with a measuring device, not a mind. Yet intriguing anomalies persist. Studies on placebo effects, meditation's impact on quantum systems, and even retrocausality experiments hint that intention and attention might have subtle but measurable effects on physical reality. The ultimate question isn't whether observation shapes reality. We know it does, at least at quantum scales. The question is whether we could refine that influence, hone it like a lens until the universe itself bends to our gaze. If so, the greatest journey might not be outward but inward, into the quantum depths of perception where seeing isn't just believing, it's becoming. From quantum bridges humming between entangled particles to cosmic strings, vibrating across dimensions, from the holographic code of reality itself to the universe shaking echoes of colliding neutron stars, we've journeyed through 30 audacious theories that dare to imagine stepping beyond the confines of our cosmos. Each one is a radical rethinking of what's possible, a testament to humanity's refusal to accept that we're stranded in a solitary reality. Whether it's the chilling precision of quantum suicide steering consciousness toward survivable branches, or the fractal whispers of plasma filaments humming in harmony with other worlds, these ideas don't just push boundaries, they dissolve them entirely. Consider the sheer diversity of approaches. Some seek doorways in the scars of ancient universe collisions, while others grow living gateways from mycelium networks or manipulate the Higgs field to rewrite physics on demand. Some theories exploit the chaos of quantum foam, while others ride the gravitational waves of synchronized black holes in parallel realities. The boldest twist observation itself into a tool, suggesting that the act of seeing might be the first step toward becoming. What unites them all is a single, electrifying premise. We are closer than ever to proving we're not alone in existence, and closer still to stepping into the proof. But here's the real magic. These aren't just science fiction. They're active frontiers of research, with labs worldwide hunting for anomalies in cosmic microwave background maps, probing neutron star echoes, and even engineering time crystals. The race isn't just theoretical, it's experimental, unfolding now in particle colliders, quantum computers, and telescopes scanning the skies for cracks in reality. Every unexplained particle behavior, every gravitational wave glitch, could be the first breadcrumb leading us to the multiverse's threshold. So now it's your turn. Which of these 30 visions of parallel universe travel leaves you awestruck? Is it the haunting elegance of black holes birthing white holes in another reality, or the spine-tingling possibility that dark matter's hidden web is already threaded with gateways? Maybe you're drawn to the audacity of hacking the simulation we might live in, or the poetic symmetry of fractal plasma resonating with worlds beyond. Drop your thoughts below. Let's debate, dissect, and dream together, because the greatest discoveries begin with a single question. What if we're not just explorers of space, but pioneers